Can you imagine real-time video communication from Mars? What if we were able to receive larger amounts of data from deep space missions faster than ever before? Picture that for a moment. In the grand scheme of space exploration, communication is not merely an afterthought, it's an absolute necessity. Unfortunately, our current spacecraft communication systems face a certain bandwidth bottleneck. This is a bit like trying to stream a high-definition movie over a dial-up internet connection. It's just not fast enough, and as our spacecraft instruments grow more powerful, they generate more data. This data is invaluable, giving us unprecedented insights into our universe, but what good is it if we can't efficiently transmit it back to Earth? The capacity to send these larger amounts of data becomes crucial. So, how do we solve this problem? The answer may lie in a new technology known as deep space optical communications, but we'll delve into that in our next segment. The future of space exploration is not just about reaching farther into the cosmos, but also about communicating more effectively and efficiently. In October 2023, a significant milestone was achieved in the field of space communication. NASA launched the Psyche mission to study the metal-rich asteroid 16 Psyche. This wasn't just any ordinary space mission. The Psyche mission had a dual purpose. Firstly, it aimed to explore 16 Psyche, an asteroid that offers a window into the violent history of collisions and accretion that created terrestrial planets. But there was another, equally important objective. The mission was also designed to test a cutting-edge laser communication technology, the Deep Space Optical Communications, or DSOC for short. DSOC is a revolutionary technology that could potentially solve the bandwidth bottleneck faced by current spacecraft communication systems. It boasts data transmission rates 10 to 100 times greater than existing radio systems. This leap in technology is crucial as spacecraft instruments become more powerful and send back larger amounts of data. This mission wasn't just about studying an asteroid, it was about testing a technology that could revolutionize space communication. The Psyche spacecraft was equipped with a new technology called Deep Space Optical Communications, or DSOC for short. This technology is a revolution in the realm of space communication, harnessing the power of infrared lasers to transmit data across the vast expanse of space. You see, DSOC is not just a fancy gadget, it's a potential solution to a problem that's been plaguing space communication for years, the bandwidth bottleneck. As spacecraft instruments become more powerful and send back larger amounts of data, the traditional radio systems simply can't keep up. But DSOC, with its data transmission rates 10 to 100 times greater than those of radio systems, promises to break this bottleneck wide open. Imagine the possibilities: real-time video and imagery from Mars, comprehensive data from distant celestial bodies, all delivered to your living room faster than ever before. The first test of this technology was conducted between the Psyche spacecraft and the Hale telescope at Caltech's Palomar Observatory. Using infrared lasers, the two communicated successfully, marking the DSOC's first light. This was a moment of triumph, the first real proof that DSOC could live up to its promises. However, like any new technology, DSOC comes with its own set of challenges. It requires precise pointing, meaning the spacecraft and the receiving station on Earth must align perfectly to communicate. And then there's the issue of latency, the delay between sending and receiving data. Despite the challenges of precise pointing and latency, the successful test of DSOC represents a significant achievement for NASA. It's a beacon of hope in the quest to explore the uncharted territories of space and bring their secrets down to Earth. So what does this success mean for the future of space exploration? The potential of deep space optical communications, or DSOC, is truly astronomical. With data transmission rates 10 to 100 times greater than radio systems, DSOC could revolutionize how we communicate with spacecraft, overcoming the bandwidth bottleneck faced by current systems. Picture this: real-time video communication from Mars and other celestial bodies, bringing the universe to our screens in unprecedented detail. As our spacecraft instruments become more powerful, they will send back larger and larger amounts of data. This data will be the lifeblood of space exploration, feeding our thirst for knowledge and driving new discoveries. As we push the boundaries of space exploration, it is technologies like DSOC that will be our lifeline, connecting us to the vast expanse of the cosmos.